In this video, my focus will be to solve problems and to explain the rudiments behind the motion of a body on a frictional horizontal surface. A rope is inclined at an angle of 37 degrees to the horizontal, is used to drag a 50 kg block along a level floor with an acceleration of 1 meter per second square. The coefficient of friction between the floor and the block is zero point 0.2. What is the tension in the rope? Let's say this is the horizontal floor and then this is the block of a mass of 50 kg. Okay, that means it will have a weight of mass times acceleration due to gravity. Since the mass is 50 kg, acceleration due to gravity g is a constant and it is given by 9.8 meter per second squared. Okay, if we do this correctly, I think that should be about 490 newton. Alright, that's the weight of the object. If the object exerts its weight on the ground, because as you place this object on the horizontal surface, it exerts its weight on the horizontal surface, and the weight is equal to the product of mass and acceleration due to gravity, which we have gotten as 490 newton. But according to Newton's third law, there must be an equal but opposite reaction to this force. So the ground will also exert a force on the object, which is called the normal reaction N, and it is equal but opposite in direction. So the normal N will also be equal to 490 newton, but not in all cases. Okay, so let's see if the normal will really be equal to the 490 newton in this case. So I'll erase this now. Okay, so a rope is inclined at an angle of 37 degrees, so there is a particular rope right here that is inclined at an angle of 37 degrees to the horizontal. 37 degrees. Okay, there will be a tension on the rope always. Anytime there is a rope, anytime rope is being used in physics to do anything, either to pull or to push, there will always be a tension on the rope, and the direction of the tension is always towards it is always towards the pull of the object. So you pull an object upwards, so that's the direction of the tension. Okay, so there is always tension T on the rope. All right, the rope is used to drag this 50 kg along a level floor. Notice that we will need to resolve this force, the tension, into its vertical axis and then into its horizontal axis, so that we will be able to know the forces that act both on the x-axis on the object and the force that act on the y-axis of the object. Okay, so to do this, I will resolve it into its vertical axis and then it will appear this way on the object with its arrow facing up, and then if I resolve it to the horizontal, it will appear the same way with its arrow facing the upside. Okay, so if I resolve this, if I resolve the tension into its horizontal axis, it's a triangle, and then it will become T cos theta. That's 37 degrees because there's an angle right here, and then on the vertical axis we'll have T sine of 37 degrees. So how do I do this? I did it by, it's a triangle, and then this side of the triangle is the vertical axis, and then this side of the triangle is the horizontal axis. Let's say tx, and then this is 37 degrees, and then the hypotenuse side is the t. Let's say this is ty. So the relationship between t and ty will be that of will be gotten from SOHCAHTOA, okay, where so means sine of the angle is equal to opposite. O there is opposite, and the opposite to the angle is ty. So that's supposed to be ty upon the hypotenuse. The hypotenuse is the longest side, that's t. So if I make ty the subject of the formula by cross multiplication, then ty will be equal to t sine of 37 degrees. So that's how we arrive at this. If you make use of car as well, that's cosine of 37 degrees is equal to tx upon t, so that tx is equal to t cos 37 degrees. So that's how it is. So notice that if t cos 37 degrees pulls this object, because the question says that this force, the tension T, is used to drag this block, the 50 kg block, on a level floor at a particular acceleration. That means the object will tend to move in this direction. The object will tend to move in this direction, in the direction of the horizontal component of the tension. So if the object move in this direction, then there must be a frictional force that will oppose the motion of the object. Okay, frictional forces oppose the motion in which an object tries to move. So let's have Fr right here. Okay, the question did not record that the object is moving along the y-axis component. So we can't have friction along the y-axis component. We can only have it along the x-axis component right here. The next thing to do is to find the summation of the forces on both axes. So summation of forces on y-axis, which in other words means the net force on the y-axis, is equal to, and don't forget that the net force is a vector summation of the forces, that is the vector sum of all the forces. So I'll be adding the forces with their direction. Okay, if we assume that up here is the positive y-axis and down here is the negative y-axis, and then this side is the negative x-axis, and then this side is the positive x-axis, then it means that n is going along the positive y-axis, and then t sine theta is also along the positive y-axis, and then w will be along the negative y-axis, and it has to be equal to 0 because there is no acceleration along the y-axis. From the question did not record that the object is moving up or moving down, so the object is just moving in this direction horizontally. So acceleration in that manner, so I'll just say ay mass. Actually, the net force is supposed to be equal to ma, but because acceleration is 0, so and the product of the mass and the acceleration will still be equal to 0. So it implies that n plus t sine of 37 degrees minus 490 is actually equal to 0. Okay, let's say this is equation 1. Now to find the summation of the forces on the x-axis, then we'll have plus t cos 37 degrees moving along the positive x-axis minus fr, which is along the negative x-axis, is equal to ma, right, where a is the acceleration of the block. So we can name it ax, or we can leave it as a, where m is the mass of the object. Okay, and the mass of the object is given from the question as 50 kg. The acceleration of the object is given as 1 meter per second. So I think we are good to go. That's 50 times 1, which is equal to 50. So it means that t cosine of theta, t cos 37 degrees minus fr is actually equal to 15. Okay, 15 Newton. So fr is equal to mu n, okay, I already explained this expression, I mean this equation. I explained this equation in this video. It will be suggested up here. Okay, so Fr is equal to the mu, where mu is the coefficient of friction. In this case, mu is given as 0.2 coefficient of friction, and then n, which is the normal reaction, we have it in equation 1, so we can find an expression for n from equation 1, so we can substitute in Fr. Okay, now let's make this equation 2. So from equation 1, let's find an expression for n. From equation 1, n, to make n the subject of the formula, I will need to add 490 to both sides of the equation and then subtract t sine 37 from both sides of the equation. Or I will need to take t sine 37 to the other side and then 490 to the other side, so that I will have something of this nature. 490 minus t sine 37 degrees. So upon, then I can substitute n into Fr, so that Fr will become 0.2 multiplied by n, where n is given as 490 minus t sine of 37 degrees. So I can multiply through 0.2 multiplied by 490. That's supposed to be equal 98 minus 0.2 t sine of 37 degrees is the Fr. So I can actually substitute Fr into equation 2. If I substitute Fr into equation 2, then I'll have something of this nature. T cos 37 degrees minus Fr, where Fr is now 98 minus 0.2, then t sine 37 degrees, which is equal to 50. Okay, so t cos 37 degree, upon distribution of the minus sign, then I'll have something of this nature. Minus multiplied by minus, which will become positive, then 0.2 t sine 37, which is actually equal to 50 as well. Notice that we want to make t the subject of formula, so to do this, then I can have something of this nature. T cos 37 plus 0.2 t sine 37 is equal to 50 plus 98 by taking minus 50 to the other side. Now t is common to both sides, so that I can have cosine of 37 plus 0.2 multiplied by sine 37, which is actually equal to, okay, so 0.2 multiplied by sine 37 is about 0.12 plus cosine of 37 degrees, which is equal to 0.118. So I'll have something of this nature: t into 0.91899, and that's equal to 148. So that t is equal to 148 divided by 0.9189, and that's equal to 161 Newton. So the tension on the rope while dragging the 50 kg mass is equal to 161 Newton. Let's solve the next practice problem. A hockey puck is given an initial speed of 20 meters per second on a frozen pond. The puck remains on the ice and slides 120 meters before coming to rest. Determine the coefficient of kinetic friction between the puck and the ice. So let's say this is the puck. The puck is like a ball. Okay, it's given an initial velocity of 20 meters per second. U is the initial velocity on a frozen pond. Okay, so and it then travel a distance of 120 meters. a distance of 120 meters. Notice that frictional force, in order to determine the coefficient of kinetic friction, we need to use the frictional force formula, which is equal to mu n, where mu, which is the coefficient of kinetic friction, is equal to frictional force upon the normal reaction. The frictional force in this case is equal to the force on the pork, and that is actually equal to ma. That's equal to minus ma, because it is along the negative acceleration. That is the object moves in this manner, and then the frictional force opposes the motion and move in this manner. So this is plus a, and then this is minus a, due to the frictional force. Okay, so the frictional force on the object is the force on the pork, and it acts opposing the acceleration of the object, which is minus ma. Okay, upon the normal reaction, the normal reaction is the force that the ice exerts on the object. Okay, so let's first of all see the force that the pork exerts on the ice, and that's supposed to be its weight, which is equals to mass times acceleration due to gravity. Okay, so it will be given as mass and acceleration due to gravity. So we can cancel out the mass of the object so that we can have minus a upon g. Okay, g is a constant, so we need to find an equation for a, which is the acceleration of the object. To find the acceleration of the object, we may make use of the equations of motion, which is v squared equals to u squared plus 2as, where v is the final velocity, u is the initial velocity, a is the acceleration of the object, and the s is the distance traveled. V is equal to 0 because the object came to rest. Okay, starting with an initial velocity of 20 meters per second, and it's the object before coming to rest in the question, so which actually means that the object stops, and by stopping, its final velocity is equal to 0. So we have 0 squared equal to initial velocity squared, that is 20 squared, plus 2 multiplied by the acceleration of the object, which is a, and then the distance traveled, which is 120 meters. Okay, 20 squared, that's supposed to be 400, and that's supposed to be 0 equal to 400 plus, and that's supposed to be 240a. So by taking 240 to the other side of the equation, I'll have minus 240a is equal to 400. If I divide both sides by 240 minus 240, okay, minus 240, I'll have something of this nature: a to be equal to minus 400 divided by 240, or 400 divided by minus 240. Either ways will arrive at the same answer, go to 1.67 negative. Okay, by substituting this value, I'll have something of this nature: minus into minus 1.67 divided by g, where g is 9.8. Okay, so if I divide this by 9.8, then I'll have 0.17 as the final answer. So the coefficient of the kinetic friction between the pork and the ice is actually 0.17, while Fr, which is the frictional force, is the force on the pork and is given as minus ma. Let's solve the next problem. A block of mass 20 kg rests on a horizontal floor. So let's have that right here. Okay, its mass is 20 kg. That means its weight, which is mass times acceleration due to gravity, that's 20 multiplied by 9.8. Okay, that's 196 Newton. Okay, then there will be a normal to the force. All right, so the coefficient of friction is this. That means mu is equal to 0.3. Mu is a constant, it has no unit. Calculate the minimum horizontal force that is required to make the body move when it is pulled at an angle of 60 degrees to the horizontal. So there is a particular pull right here, okay, and it is at an angle of 60 degrees to the horizontal. So we will have something of this nature. 60 degrees force that is applied, let's say the force is P, so this place will be Px, and then there will be a vertical component of the force as well, which the arrow will not be in that direction. The arrow will be in the same direction as P, which is upward. So that will be Py. Okay, by resolving P into Py and resolving P into Px, we can't use P just like this. We always need to resolve it into its x-axis component and its y-axis component. If I resolve it to Px, just like what I did in example 1, I'll have P cos 60 degrees, and then Py will be equal to P sine 60 degrees. Okay, so if the object is meant to move in this direction due to the pulling of force, due to the pulling by force P, then there must be a frictional force that will oppose the motion of the object, which is actually Fr. So summation of the forces on the y-axis, summation of the forces on the y-axis, N, that's plus N, then plus P sine 60 degrees, then minus 196 is equal to 0, with reasons that I already told you. The object is not accelerating up or down the horizontal surface. The object is just moving horizontally, not vertically. So there is no acceleration on the y-axis, which is the vertical component. So let's find the summation of the forces on the x-axis. On the x-axis, we have plus P cos 60 degrees, which is along the positive x-axis, then Fr is along the negative x-axis and is equal to ma. Okay, where m is the mass of the object and a is the acceleration of the object. Now let's see if there is an acceleration for the object. A block of mass 20 kg rests on a horizontal floor. Rest actually means that the object is not moving yet. Okay, the object is at rest, so force P is meant to move it, in that direction, in the positive x direction. So at that minimum value, the minimum point, at that minimum point, acceleration is equal to 0. Okay, or if you don't understand it that way, you may understand it this way. The minimum value of P that will be able to pull the object along the direction of P, that is the minimum value of P which will be able to pull the object horizontally, that is along this direction, it has to be equal, it has to be greater than or equal to the opposing force. You understand? And in this case, the P that we have on the horizontal is P cos 60 degrees. It has to be greater than or equal to Fr. If it is not greater than Fr, it will not be able to move the object. If it is equal to point Fr, that means it is ready to set the object in motion. So the minimum value is at the point of equal to P cos 60 is at the minimum value is at the point of equal to, okay, then later other values which are greater than Fr can also move the object, but this is the minimum, the smallest value that will be able to, the smallest value of P that will be able to move the object in that direction. Okay, so the point of equality is the point at is the minimum point. So there are still other values of P that can still move the object. So but that point where it is equal, where P cos 60 is equal to Fr, is the smallest point is the smallest value of P that can push the object in that direction. So we get to have P cos 60 degrees to be equal to FR. So if you accept that A is also equal to 0 right here, then P cos 60 degrees minus FR will be equal to 0. And that will mean that P cos 60 degrees is equal to FR, just like what I have here. Okay, so not forgetting that FR is actually equal to mu n. Okay, so we can get an expression for n from equation 1. From equation 1, n is equal to 196 minus p sine of 60 degrees. Okay, so upon substitution, I will have P cos 60 degrees to be equal to mu, where mu is the coefficient of friction and is given as 0.3 multiplied by the normal reaction, which is 196 minus P sine 60 degrees. Then I can close the bracket so that I will have P cosine of 60 degrees to be equal to 0.3 multiplied by 196, and that's equal to 558.8 minus sine 60, which is supposed to be root 3 upon 2 multiplied by 0.3, and that's equal to 0.2598. Then I can close the bracket. So cos 60 as well is equal to 0.5, so that I will have 0.5p to be equal to 58.8, then minus 0.2598p. So if I take minus 0.2598p to the other side of the equation, I'll have 0.5p plus 0.2598p to be equal to 58.8. So 0.2598p plus 0.5, that's equal to 0.7598p. And that's equal to 58.8. So I can divide both sides of the equation by 0.7598, 0.7598, so that I will have something of this nature: P to be equal to 58.8 upon 0.7598. Okay, which is equal to 77.39 Newton. So the force, the minimum value of P, the smallest value of P that is required to make the object move, is 77.39 Newton. But if I also apply a force of 80 Newton, it will make it move. So P greater than or equal to 77.39 Newton is the force that will move the object. It will always move the object, but the minimum value is at the point where P is equal to 77.39 Newton. So that's the idea. Let's solve the next problem. Calculate the coefficient of friction of a block of mass 70 kg moving at a uniform speed when pulled along a horizontal track with a rope which makes an angle of 55 degrees with the horizontal. The tension on the rope is 350 Newton. So let's have the diagram right here. And this is the object with a mass of 70 kg. That means it will have a weight of 70 multiplied by 9.8, okay, which is equal to 686 Newton. All right, and then there will be a normal reaction. Okay, the object, the mass is pulled by a rope which makes an angle of 55 degree with the horizontal. So I'll have something of this nature. Pulled, this is the direction of a pull. Okay, down here is the direction of a push. All right, so you get to, and if it is a rope, there will be a tension on the rope, and the tension on the rope has already been given in the question as 350 newton. Okay, so, and it is at a particular angle to the horizontal. The arrow will always follow that direction, 55 degrees. So I will need to resolve it into its vertical component as well. So this has to be 350 sine 55 newton 55, while this is 350 cosine of 55 degrees. All right, so if the object decides to move in this direction, then there will be a friction in this direction, which is given as Fr. So to find the coefficient of friction, notice that the formula for coefficient of friction is Fr upon the normal reaction. So we need to find an expression for normal reaction, and then Fr, then we'll be done. Okay, so to find, we need to do summation of forces on the y-axis, and that's supposed to be equal to n plus 35 or 350 sine 55 degrees, then minus 686 equal to 0. So I just need to make n the subject of the formula. N will be equal to 686 minus 350 sine of 55 degrees. So that's my n. So let me just have it right here. So n is equal to, okay, let me simplify further. 350 sine 55, 286.7, then I'll have 686 minus that answer, that's equal to 399.297, 399.297 in Newton. Okay, so I'll have 399.297. So let's find an expression for the frictional force. Summation of force on the x-axis, okay, that's supposed to be equal to 350 cosine of 55 degrees, then minus Fr, for reasons that I already explained, is equal to ma, right? Notice that m is the mass of the object and a is acceleration, but the object is moving at a uniform speed. Okay, so those are things that you should underline in the question. If an object moves at a uniform speed, acceleration will be 0. So we can have mass multiplied by 0, the mass of the object multiplied by 0, which is also 0. So that's 350 cosine of 55 minus Fr is actually equal to 0. So that Fr is equal to 350 cos 55 degrees. So we can do that. 350 cosine of 55 degrees, that's equal to 200.75. 200.75. So I can have 200.75 right here. So that divided by 399.297. Okay, that's supposed to be 0.5, and it has no unit. Okay, anytime you find the coefficient of friction, if you have answers that is greater than 1, then you know that something is wrong with your answer, because coefficient of friction ranges from 0 to 1 depending on the material.